In this next section, we are going to continue to look at sequences and series, and we're going to focus mainly on arithmetic sequences. And up here, I have an example of a sequence starting at 1. This is my first term. So my first term is 1, then I have 3, then I have 5, 7, then 9, and I can continue if I put the dots there. But if we notice the rule from getting from the first term to the next term, I'm adding 2. And from the second term to the third time, I'm adding 2. And any time within this sequence, from one term to the next term, I'm adding 2. So the definition of an arithmetic sequence is the difference between two successive terms, so from one to the next, is always the same. And we talked in the last section about recursive sequences, and we can say that if we know the first number, we have to have a rule to get to the next term. So this is the rule. I'm going to go to the next term. To do that, I'm going to look at the previous term and then add the difference. So if I want to get to this term, this would be a sub 3. If I want to get to the third term, I have to look at the term before it. So 3 minus 1 is 2. So I have to look at a sub 2 and then add 2, and that would give me my value. So this rule really means to get to the next term, I look at the term before it, that's this part right here, and add the rule. That rule is called the common difference. So that means if I take the one before it or if I take a term and subtract the one before it, that would give me my common difference. If my rule is positive, my numbers are going up. But if my numbers are going down, like I have 10, 7, 4, 1, here my rule would be minus 3. To get from 1 to the next, I have to subtract 3. So my rule, my common difference, if it is negative, that means my numbers are going down. So in example 1, it says, determine if the sequence is arithmetic. So if a sequence is arithmetic, then from 1 to the next, it has to have the same common difference. So if I look for the rule, this is plus 2. From 4 to 6, I add 2. 6 to 8, I add 2. 8 to 10, I add 2. So since my rule is the same, this is an arithmetic sequence. And if it is an arithmetic sequence, usually we have to identify the first term. So my first term is 4, and my rule or my common difference is 2. Now I could write this as a recursive rule, and in a recursive rule we have to have a starting point, which is the first term. So a sub 1 is 4, and then to get to any term or the next term, I always look at the previous term and add 2. So this would be my recursive rule. You have to have a starting number and the rule. In example 2, it says to show that the following sequence is arithmetic, find the first term and the common difference, just like we did up here. So here, if I were to just list some of the terms, so A1 or S1 would be 3 times 1 is 3 plus 5 is 8. My second term would be 3 times 2 is 6 plus 5 is 11. My next term would be n is 3. 3 times 3 is 9, plus 5 is 14. Let's do one more. My fourth term is 12, plus 5 is 17. Now, in this one, we can see that our first term is 8, and my rule, my common difference, is to add 3 each time. Now, if I wanted to write the recursive rule, it didn't ask us to here, but I think you will have to in your assignment. My recursive rule would be, I start with 8, and then to get to the next term, I have to look at the previous term and then add 3. And this is my recursive rule. So example 3 says to show the following sequence is arithmetic. So we're going to do just like we did up here. Let's make a list of terms, starting out the sequence. So if n is 1, I have 4 minus 1 is 3. If n is 2, 4 minus 2 is 2. Then if n is 1, if n is 3, 4 minus 3 is 1. In the fourth term, n is 4, 4 minus 4 is 0, n is 5, I get negative 1. I can keep going. But here, the first term, a sub 1, is 3. And my rule each time is down 1. So this time I have a negative common difference. So my common difference is negative 1. And just again, writing the recursive rule, a sub 1 is 3. And then to get to the next term, I look at the previous term and then subtract 1. That's my rule. Now, sometimes it's not to our benefit to make a list of numbers. Let's say I wanted to find the 23rd term. I don't want to have to make a list of 23 numbers and do all that calculating to be able to find that. So we do have a formula that lets us just plug in the term that I want to find as long as I know the first term and the common difference. So we're going to use this formula quite a bit. So on the next page, it's asking us to find the 41st term of this sequence. Now I'm going to write the formula back here again. So that's the formula. Now in this case, I want the 41st term. So my n value is going to be 41. In my sequence that I'm starting with 2 and 6 and 10 and 14, my first term, a sub 1, is 2, so I'm starting at 2, and my common difference is 2 plus 4 is 6, so I'm adding 4 each time. So my common difference is 4. So if I want to find the 41st term, so this is a sub 41 equals my first term, which is 2, times n, which is 41 minus 1, 41 minus 1, times my common difference, which is 4. Oops, this should have a plus in here. Forgot that, sorry. I didn't write the formula correctly. Now we have it right. So the 41st term is going to be 2 plus, this is 40, 41 minus 1 is 40 times 4. So order of operations, this is 2 plus 160 or 162. So the 41st number in our sequence is 162. All right, so for this next one, it's asking us to find the 8th term of the sequence. Oh, they tell us that the 8th eighth term of the sequence is 75. So a sub 8 is 75. And the 20th term, or 20th, yes, 20th term is 39. So a sub 20 is 39. All right, so I have a sub 8 is 75, a sub 20 is 39. We want to find the first term of the common difference. Well, how about if I write that here? Let's say I have a sub 8 is 75 and a sub 20 is 39. Now, I know by using this rule, if I want to find the first term, I can plug in what I know a sub 8 is going to be 8 minus 1 times d, and here I can solve a system of equations. So if I use this and say that for a sub 8, 75 equals a sub 1, I don't know that, times n minus 1, I know n is 8, so I have 8 minus 1 times d. So I have two unknown variables here. I don't know the first term and I don't know the common difference. But let's make another sentence but with what we know for a sub 20. We know a sub 20 is 39. I don't know the first term. I do know that n in this case is 20 minus 1, and I can find my common difference. And again, I have to add these to get the right formula. All right, so I have two equations, two unknowns. I can make a system of equations. So if I simplify this a little bit, I can say that 75 is a1 plus 8 minus 1 is 7 times d. This one is 39 equals a1, and then this one would be 19 times d. Now, if I were to take these two sentences and subtract them, I would be able to cancel out my a1s. All right, so if I subtract the two sentences, the a1s would cancel. 75 minus 39 is 36, and that would equal negative 12 times d, so my common difference is going to be negative 3. Okay, so that's going to help. I found my common difference, that's negative 3. Now to find the first term, I just need to plug in negative 3 in for one of these common differences, or into one of these equations. So if d is negative 3, let's plug that in here. I'll have 75 equals a sub 1 plus 7 times negative 3, which is negative 21. If I add 21 to this side, I'm going to get 96. So a sub 1 is 96. Okay, so we did part A. Now in part B, it says to give a recursive formula for the sequence. Now a recursive formula, this is all part A here, means we have to have the first term and then we write the recursive rule. So the first term is a sub 1 is 96. And to get to the next term, we look at the previous term and subtract 3. Okay, so this is my recursive rule. I have a starting value, and then this is my rule. In part C, it's asking what is the nth term of the sequence. Okay, so that means I'm going to go up here and I'm going to put in n for my rule. Or I'm just going to leave it, this is n. But I'm going to substitute what I know for the first term and the common difference. So I know a sub n equals the first term, which is 96, plus n minus 1 times my common difference, which is negative 3. And if I simplify this, I have 96, and then this would be minus 3n plus 3. So this would be 99 minus 3n. And that would be the equation to find the nth term. All right, so these are all having to do with sequences. Now in a series, remember, we take that sequence and we add up all the values. So down here, this just shows us there's actually two formulas that we could use. This just shows us that we're adding up all the terms in a series, in a sequence, and this gives us the summation value of that. But there are two formulas here that we can use, and I prefer this one. Whoops. I prefer this one because it's shorter and just simpler. So in example 6, it asks us to find the sum of the first n terms of the sequence. All right, so I want to add them all up. I first have to find, if I'm going to use this formula, n is just going to equal n because it doesn't tell me how many there are. I need to know the first term, so a sub 1 is, if I plug in 1 into my rule, I have 3 times 1 is 3 plus 5 is 8. So the first term is 8, and I also need to know the last term, which is a sub n. So if I put in a sub n here, I have 3 times n plus 5. So instead of k, I'm just plugging in n. So this is 3n plus 5. So to find the equation, or to find the sum of them, I'm going to take this formula, and I have n over 2. N stays n because I don't know the number we want to go to. And I'm going to add the first term. The first term is 8 to the last term, which is 3n plus 5. So I'm adding 8. This is the first term. This is the last term. I'm adding these together. So this is n over 2 times 8 plus 5 is 13 plus 3n. Okay, so we're going to have a little abstract answer. We're not going to get a number answer here because I don't have a value for n. But I bet in the next one I will. So here it says to find the sum of all these numbers. Now here's our formula. A sub n equals, whoops, that's not what I want. I want to find the sum of all of the terms. I'm going to have n divided by 2 times a sub 1 plus a sub n. All right, so what I don't know here, I know the first term, I know the last term. Okay, so a sub 1 is 60. A sub n is 120, but I don't know what n is. Now, I could look at this and I could say, okay, I'm adding 4 each time. So I could make a list of numbers. I can go from 72, 76, 80, and I can count how many numbers are in between there. But I could also use my formula where a sub n equals a sub 1 plus n minus 1 times the rule. I can use that formula because I know the last term is 120. I know the first term is 60. I don't know what n is, but I do know that my rule is multiply by 4. All right, so if I just solve this equation for n, that's going to tell me how many terms are here. So this is 60, and then this is 4n minus 4. So 64 is 4n, and n is 16. So technically, I would have 16 numbers in this sequence. So n is 16. Now I can use the sum formula where I take s of 16. I'm adding up the sum of 16 numbers. That gives me 16 divided by 2. My first term is 60. My last term is 120. 60 plus 120 is 180. And this part here is 8. So 8 times 180 is 1,440. And that would be the sum of all of the numbers, all 16 numbers of the sequence. And this last example here they give us a picture and it describes, or it shows a ceramic tile floor, and it's in the shape of a trapezoid. It's 20 feet wide, so there's 20 tiles this way, and at the top there are 10 tiles. And I can just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so the bottom has 20, the top has 10, and they're placed in a row where each next row has one less tile. All right, so I want to find the sum of all of the tiles in all of the rows. All right, so here's my sequence here. I have 20, 19, 18, 17, and I want to go down to 10. And I want to find the sum of all of these numbers. So if I use my formula here, where s sub n equals n over 2 times a1 plus an, I can look at this picture and I can count how many rows there are. So if I start here, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So n is 11 rows. All right, so I have s sub 11 is 11 divided by 2. The first row has 20, and the last row has 10. Oops, and that's plus 10. So this is 11 divided by 2 times 30, or 11 times 15 is 165 tiles. All right, so that is all about the arithmetic sequences and series.